So for our next section on writing the equation of a line, section 5.2, we are going to take what we learned in 5.1, where we graphed lines and we found their slopes, and now we're actually going to take that same sort of data and get a relationship rather than a visual relationship like a graph. We're going to take the data and we're going to come up with an actual mathematical equation that will model the trends of the data. So to do that, I want to write out a couple of steps first. I want to define what an equation of a line is. So let's start there. Let's define an equation of a line in what is called, and this is the only form we're going to use, slope-intercept form. So now we are going to, rather than having a graphical relationship between x and y, we're going to have a relationship y equals mx plus b. Okay? So that's the equation of a line where m equals the slope, which, by the way, we already know how to find the slope. So between 2 points, I'll just remind us that that's y2 minus y1 over x2 minus x1. Rise over run. So remember, we already know this comes from the last section. We know how to find the slope. Okay, so nothing new there. And b gives us what we call the y-intercept of the graph. Okay? So B represents the y-intercept of the graph, or is the y-intercept of the graph. So if we were to have an actual visual, right, and we're going to have graphed this data. We're going to work with the same data we worked with when we graphed it and calculated slopes in the last section. We'll work with the same data sets. We're going to have some line, and let's just suppose when I graphed the trend line that it looked something like this. And so I've got a set of, I have my set of scattered points around the line, and I'm looking for the trend line. Okay, because we're working all with real world data. So we've got some kind of set of scattered data, and we draw in the trend line with our ruler. And that trend line has a slope of m. Again, remember, slope is rise over run as well. It's another way to think of it. And then this point right here, where it actually crosses the y-axis, this point right here is 0b, meaning this point on the y-axis, that where it's crossing the y-axis, that number where it crosses the y-axis is b. Okay, so I want to write up the steps to find the equation of a line and then go through a couple of examples. And they're pretty basic steps. We're going to start with what we did. So to find an equation of a line between, and we're going to pick any 2 points. We tend to want to pick, just like when we were doing the slope, we want to pick the points that are closest to the trend line we draw in. So to find an equation of a line between 2 points, x1, y1, and x2, y2. What we want to do is we want to follow a couple of steps here. So we are going to follow, the first step is we are going to find the slope. So we're going to use our slope formula and we're going to find the slope just like we did in the last section. So everything we're doing here is going to start off very much like we did in the last section. So find the slope m by going y2 minus y1 over x2 minus x1. So that's the first thing we do. We're going to find the slope. Now I'm going to go ahead and pull up a sample, and we're going to follow these exact steps with some numbers. Okay, so here's our example. If we wanted to find the equation of the line through, and I just grabbed 2 very simple points, right? We would pull these off of our data set, but to go through the example, the first example, let's just work with 2 ordered pairs that I came up with so that we'll have nice clean numbers for this first one, and then we'll get into some real world data. So remember, the first thing that we do is we find the slope. So to find the slope, So first step, find the slope. Find the slope, m equals, again, we're going to label these x1, y1, x2, y2, just like in the previous section, and we plug those in. So 11 minus 7 over 4 minus 2. And when I do that, I get 4, you can plug that into your calculator. I picked these numbers, so we had nice clean numbers here. So the slope is 2. Okay? So that's our first step. Start off by finding the slope. After we have found the slope, the second step is to actually plug that slope into the slope-intercept equation. So plug the slope, which again, remember we call m, into the slope-intercept form of a line. So we go y equals, now we know m, we just found m, so we're plugging in m, x plus b. Okay? So back to our example. So we're actually going to plug in, here's that second step, plug in m, which is the slope. So we take y equals, it's y equals mx plus b, so I replace the m with 2, x plus b. And we're halfway there. We almost have found the equation of the line. Remember, the equation of the line is a relationship, just like a graph is a relationship between x and y. So we're trying to come up with the other two variables. Now we have m, and we need to just find b. Okay, so now the third step is to pick one of the points, doesn't matter which. Okay, so pick either of the points. So pick one of the points, right? And they are xy points, x1, so to pick x1, y1 or x2, y2, and plug into the equation and solve for b. Let's say simplify and solve for b. Okay, so let's come back over here. So our third step, we're going to plug in, we're going to pick a point and plug it in. Now, it doesn't matter which of these points I pick. So, pick 2, 7 or 4, 11. Your work will look a little different, but the value of b will be the same regardless of which of these two you pick. So I am going to just pick 2, 7. Okay? So that's the point I'm going to pick. So pick 2, 7, and I'm going to plug it in. So remember, this is x. The first coordinate in the ordered pair is x, and the second coordinate is y. So when I go to plug that in, I'm going to plug in 7 equals 2, remember the slope was 2, times, and then x is 2, plus b. Okay, so I plugged in the x and the y there. So I end up with, now simplify that, so do the 2 times 2, so 7 equals 4 plus b. And then solve for b. That's the last thing. So I found m in the first step, and now I'm finding b in this third step. So I'm finding the value of those two variables for this equation. So now I'm going to just subtract 4 from both sides. And I find that b is equal to 3. Okay? So I had m in my first step, and now I have found b. Okay, one last step. The last step is to write the equation with the values we found, for m and b. Okay? We will also in this step define x and y in context. Now, for the example that we're working, we do not have any context, but we will have context in all of our problems when we work with tables of real world data. So when we have context, we'll also describe what x and y represent. Okay? So our last step over here, now this is actually the meat of our process. We're actually going to write the equation. Okay? So we don't want to forget this, right? Like we've done all this work to find m and b, so you don't want to go through the first 3 steps and then not actually write the equation. So now that you have m and b, m is 2, b is 3, we're actually going to write the equation. So y equals 2x plus 3. And that is my answer. Okay? So that is the answer when we're trying to write the equation. Now that represents a relationship for x and y, and that's what we'll do in 5.3. We'll say, okay, once we have that equation, what do we do with it? Well, we can use it to make those predictions that we did from the graph, or we could use it to model the data in lots of ways. So given an x value, we could find the y values. Given a y value, we could find the corresponding x value. All of those sort of things. So this is very useful. It's very useful to have this equation. We have graphical representations, but we also have mathematical equations that model data. And model data means represent the data. Okay, so let's do one quick example here with the dosage of medicine. So let's do this example. If I wanted to find, so here's an example that we did in 5.1. We graphed this data. But what if we wanted to write the equation of this data, not a visual representation, but an actual mathematical equation that represents this data? How would we do that? Well, we would start by picking 2 points. So we're going to pick 2 points from the data. For this one, and I'm just going to pick the points here. So I'm going to say, why don't we just pick this ordered pair? Sometimes we're given the choice. Let's pick that ordered pair and this ordered pair. So let's take those 2 ordered pairs and let's write them over here. So we have 97 and 70, and we have 156 and 100. So let's take those 2 ordered pairs and let's represent the line with an equation using those 2 ordered pairs. So this is my x1 and my y1. This is my x2 and my y2. And my first step is to find the slope. So to find the slope, remember y2 minus y1 over x2 minus x1. So my slope here is going to be 100 minus 70 over 156 minus 97. And I plug that into the calculator. So I go to the calculator, and 100 minus 70, I'm actually plugging it into my calculator right now, 156 minus 97, and I end up getting 30 over 59. Now I want to work with the decimal, so I'm going to go ahead and just convert that into decimal form. And so that is approximately, and you will have rounding instructions, but let's just say we wanted to go to 2 decimals, so 0.51. Okay? So it's approximately 0.51. Now there is context here. We talked about the context when we did the last section, but I'm going to just leave it without units for right now, and we'll describe and define x and y when we write the equation. Okay? So there is my slope. So I've got my slope. Once you have the slope, you're going to plug it into the equation. So y equals 0.51x plus b. Okay? So step 1, find the slope. Step 2, plug the slope in. Step 3 is pick one of these points, and I am going to just pick this first point, and I'm going to plug it in to the equation. Okay? So I'm going to get 70, because that's the y value, equals 0.51 times 97 plus b. Well, first thing, and then I'm going to simplify. So first thing I'm going to do is take that 0.051 and multiply by 97. And that gives me 49.47. So just doing a little simplification right there. Just plug that into the calculator, right? No magic there, just plugged it into the calculator. And now I'm trying to find B. So now I'm going to subtract that 49.47, subtract that 49.47 from both sides of the equation so that I find that B is equal to, so take 70 minus 49.47 on the calculator, and I find that B is 20.53. So I have now found my slope. Okay, so here's my slope, and now I have found B. Okay, so to write the equation of a line, you need two things. You need M and you need B. So we know how to find M from the last section. We find B following this process, and then we put those two things together. So this is M and B. So take your M and your B, and now actually write the equation. So don't ever stop before you've written the equation. Don't do all that work and then not write the equation. So y equals 0.51x plus, what do we find for b? 20.53. And this is where we have to also describe what x and y represent. So we'll always, after we write the equation, we'll define what x and y are. And in this particular case, x is the weight in pounds of a patient. So we say weight in pounds. And y represents the dose. So this is the dose of medicine. Dose of medicine in milliliters. I believe it was milliliters. Let me check. Yeah, in milliliters. And this is our answer. What we'll do with it is now we can use this. So let's just suppose, like, here's just kind of a little extension, right? So here's an extension off of this. Let's just suppose that I wanted to find what dose should, the predictions we were making off the graphs we can make with the equation now. So what dose should a patient that weighs 163 pounds receive? Okay. So a patient that weighs 163 pounds, well, this is why we write x and y, because that is definitely an x value. So if x is 163, we can figure out what the dose should be by plugging in 163 for x. And then it just becomes a problem from back in volume 1. Now we're just plugging in a number into a formula and seeing what we get back. And so I'm just going to take that real quick to finish this example off. 0.51 times 163 plus 20.53. And I find that that patient should receive 103.66, or approximately 104 milliliters of the medicine. Okay. And that's what we're going to do. So this little extension, this is 5.3. Once we have these equations, we're actually going to use them. But I think it's really important. Like, why are we going through this work? Well, we're going through the work so that we have a model that we can use to predict data or to make conclusions about other data than what's given on our table. Okay, so let's just summarize real quick here. We want to make sure that when you're writing the equation of a line that you follow this process. So find the slope, plug the slope in, pick one of the points, plug that point in to find your b, and then write your equation. So follow those 4 steps. All right, we'll do some more practice in our class sessions and in some examples.